Welcome to the new section of this course, the neural networks. In this section, we will start with Perceptron Classifier, then move on to multi-layer perceptron. Next, we will be stacking with a neural network and finally creating a simple estimator. Now let's move on to the video, Perceptron Classifier. In this video, first we will load the UCI diabetes classification dataset, then split the dataset into training and test sets. After that, import a perceptron. Next, we will instantiate the perceptron, then train the perceptron, and finally try the perceptron on the testing set, or preferably compute cross-validation score. So let's start with importing libraries, then load the UCI diabetes dataset. Add the web location of the Pima Indians diabetes dataset as a string as highlighted here, and is also available in the code bundle. Add the column names of the data in a list. Then store the feature names as a list. Exclude the target column, the last column name in column names, because it is not a feature. After that, make a pandas data frame to store the input data. Set the input variables x and the target variable y. You have loaded x, the set of input features, and y, the variable we desire to predict. We will split x and y into testing and training sets. Do this by stratifying the target set, keeping the classes in balanced proportions in both training and testing sets. Post that, we will scale the set of features. Here in this code, we will perform the scaling operation on the training set only, and then continue with the testing set. Next, we will import Perceptron. Then, we will instantiate and train the Perceptron on the training set. Let's run it. And here is the output. Now we will import some libraries to measure the cross-validation score. In this, we will pass ROC-AUC as the cross-validation scoring mechanism. Additionally, use a stratified k-fold by setting CV as SKF. After running it, you will get the value as 0.766. Following that, we will measure the performance on the test set. Import two metrics, accuracy score and ROC-AUC score, from the scikit-learn.metrics module. With these commands, we will see the classification accuracy and ROC-AUC score. Run this, and here is the desired output. The test finished relatively quickly. It performed okay, a bit worse than logistic regression, which was 75% accurate. Try running a grid search by varying the perceptron's hyperparameters. Some notable parameters include regularization parameters, penalty and alpha, class weight, and maximum iteration. The class weight parameter deals well with unbalanced classes by giving more weight to the underrepresented classes. The maximum iteration parameter, that is warm start, refers to the maximum number of passes through the perceptron. In general, the higher its value the better, so we set it to 50. Here we have used n iteration instead of maximum iteration. So use this grid search code. Run it. Now let's look at the best parameters using this command. Run it, and here are the best parameters. Next, let's check the best score using this command. Run it, and here it is around 0.7885. Varying hyperparameters using cross-validation has improved the results. Now try to use bagging with a set of perceptrons. So for that, we need to start by noticing and picking the best perceptron from the perceptron grid search. Cool, we got the best perceptron after running it. Next, we will perform the grid search to pick the best estimator. So first, we will import the bagging classifier. Then, we'll create the parameter distribution. With these commands, we will perform the grid search. Look at the new cross-validation score using this command. And it is around 0.826. Now we will check the best parameters. These are the best parameters that we have got. Thus, a bag of perceptrons scores better than a single perceptron for this dataset. So here we have come to the end of this video.